By far the most popular question that gets asked is this question here, question 5 from the 2018 methods exam. It's a tough one. Okay, we've got two functions, what looks to be cubic and a linear function. Parameter A is a positive real number. All right, so let's get our function definitions ready. F of x equals 81x squared times a take x all over 4a to the power of 4, and define h of x equals 9x over 2a squared. Okay, find the coordinates of the local max of f in terms of a. So let's diff f of x, solve the derivative equals 0. So we want to find the stationary points. Stationary points occur in two places. Now this is a negative cubic, so negative cubics behave like that. So its min will be first, its max will be second. So a is positive, so that means that is larger than that. So it's got to be at 2a on 3 comma. Let's just do f of 2a on 3, 3 on a. All right, so that's its maximum. So 2a on 3 and 3 on a. That's where that occurs, its maximum. Its minimum is not there. Its minimum is down here. It's beside the point, but let's get that right. Okay, find the x values of all the points of intersection between f and h in terms of a where appropriate. Solve f of x equals h of x for x. That's all I need. So x is equal, so it's only the x values that are required. X is equal to 0, a on 3 and 2a on 3. So it's jumping by a on 3 each time. Determine the total area of the regions bounded by the graphs of f of x and h of x. So obviously, yeah, it intersects 3 times. One of the times is at the local maximum, and one of the times is at 0. So we know that what happens is that we get like 3 intersections. So it's going to be like a cubic that goes up at its local maximum. We're going to get an intersection there, and an a on 3 at the midpoint. So that's what it's going to look like. Let's just have another look. So we'll go to graph and table, clear out this junk. And we want to graph them. We want to use this parameter button here. So to do that, I need to actually copy and paste the graphs in. So I'm going to go to my definitions. Here's my first definition, copy, and there. Second one, grab that. A is equal to 1.5. So that's what happens when A is equal to 1.5. And you can sort of see, yeah, the linear is the top function, the cubic is the bottom function, and that's how the 3 intersections work. Otherwise, it wouldn't intersect 3 times if the linear missed, like at this point here in the middle of those values there. Let's just zoom in a little bit closer. So what do we got? Let's go from -1 to 2 on the x values. And let's chop down the y's as well. -2 to 2. Let's see if we can see it a bit better. All right, that's pretty good. All right, so now we can clearly see what we want to get. Okay, so let's start working through. So we want the area now that's bound. So we're going to do an integral at this intersection point here, which is at a on 3 and 0. Top function is the linear, which is h of x, take, not g of x, take f of x plus the second one is these two intersection points here, which is 2a on 3 and a on 3, and it's going to be f of x take away h of x dx. All right, let's go back to main. Now, remember, one of the issues with using parameters in that graph screen is that the number that was defined as a when you left there is still what the value of a is. So highly recommend when you return here, you go del var and get rid of your definition of a. Right, now when I hit a, it's just going to be a. All right, so let's get stuck into it. So now I'm going to do that integral. Not simultaneous equations. Okay, 1/8. Right, so even with parameters, the value is coming up as 1/8, which basically is saying doesn't matter what a is equal to, it'll be 1/8 all the time. It's interesting. Okay, so they've introduced a new function g of x, which is that, which is just a modified version of f of x. And they've restricted the domain. So what they've done is narrowed it down to what we found was the maximum, local maximum, and the local minimum. So we've got that restriction there. Okay, so where did that occur? Local maximum was at 2a on 3a. Okay, evaluate 2a on 3 times g of 2a on 3. It's just multiplying those two together, because that y value is g of 2a on 3. So this should be 3 on a times 2a on 3. So it should be 2. 2a on 3 times, now g, I'm using h still, h of 2a on 3. 2, yep. So what that does is multiplies those two values together. There'll be a reason why they want us to do that. Find the area bounded by the graph of the inverse function of g, the x-axis and the line g of x is equal to g of 2a on 3. So x is equal to 3a. All right, so what would happen is that would be 3a, this would be 2a on 3, and our function would do something like this. All right, so there's our inverse function, okay, and its endpoint would be 3 over a, comma 2a on 3. So what happens, remember, is the domain, so the domain of this is that, so domain of g is 0 to 2a on 3, and the range of g, so ran g, is going to be 0 to 3 on a. So that means that the domain of the inverse will be the range, so 0 to that. Okay, all right, what do they want us to do? They want us to work out the area bounded by the inverse function, the x-axis, and the line x is equal to this value here. So they want this area here. That's what they're after. Okay, now there's a way of doing this without actually finding the inverse function. Now, if you understand what's going to happen, actually this area here will be exactly the same as, I'm going to undo this, that'll be exactly the same as this area here. This area here on the original function. All right, so there's a couple of options. We could attempt to integrate on y, but the best bet is to use this answer here. Okay, so what I'm actually going to do is integrate g of x between 2a on 3 and 0 dx, and that's going to give us this area here. All right, we don't want that, we want this part here. So what I'm going to do is remove it from 2, which was the area of a square that encloses or is out of the function. Or square, it's a rectangle that goes around the function. So I'm going to do 2 take away that is going to be the area. All right, so let's see what happens here. 2 take away 2a on 3, 0. I've still called it h of x, I think. Dx is equal to 1. Okay. All right, so find the value of a for which the graphs of g and its inverse have the same endpoints. So the endpoints of g are 2a on 3, 3 on a. Let's just check that. Yeah. And g inverse endpoints will be just those flipped around. So 3 on a, 2a on 3. So basically, if I equate either the x's or the y's, what will happen is I'll solve for a, and that will mean that these two values are the same, which should by default mean that these two values are the same. All right, so let's do it. So I'm going to go solve 2a on 3 equals 3 on a for a. A is a positive real number. So (3√2 over 2). No need to explain why you discard the solution or the other solution for 1 mark. So it's answer only there. Let's just try that out. Okay, so I'm going to do 2a on 3. And if I chuck in a equals, or a equals this value here, it's √2. And if I do 3 on a with a equals that, it should be the same number, it's √2. Okay, so the two functions are going to meet, so g and its inverse are going to meet. So if we imagine this, that'll be √2 and that will be √2. So that's where they're going to meet. The endpoint is going to be the same at x is equal to √2. So find the area enclosed by the graphs of g and g inverse when they have the same endpoints. So what's going to happen is it's going to go like that and up to there. The other one is going to go like that and up to there as well. So we want this area here and this area here added together. So what I reckon we do first of all is we work out when g, so we go g of x equals x. So we want to find out where the intersection points happen. Now one of them is going to be 0, one of them is going to be √2, and I think the other one is going to be the halfway mark, which is √2 on 2, but I'm not 100% sure. Solve g of x equals x for x. I'm using h of x. So h of x equals x What's h of x? Oh God, I've forgotten what function I'm using. Solve f of x is the cubic equals x. Oh my God, what is going on here? What am I solving? G, and G is based on f. So when is f of x equal x? Well, let's do that. So solve f of x equals x when x is equal to, when a is equal to this value here, because that's really what we're doing there. My calculator just seems to be misbehaving on this one here. So what I'm going to do is, I've got my original function f of x. I'm going to sub when they have the same endpoints, which is a equals root 3 on 2. So I'm going to grab that. And that's the function where it has the same endpoint as its inverse. And what I'm going to do is then solve that equals x for x. And it's telling me that it's got an intersection at 3 places. So I expected that. That was at x is equal to 0, x is equal to root 2, and x is equal to root 2 on 2. Right, so that seems to be in sync with what happened here when we got the intersections, which is they're separated by the same interval. All right, so then to answer this, what I will do is find the area enclosed. What we're looking for is straight line, and my function goes like that, and then its inverse will wrap back around like that. So what I'll do is I'm just going to go top function take away bottom function, and then top function take away bottom function. This is on the original, and then double it to get the areas that I didn't include for the inverse. Okay, so here goes. I'm going to go root 2 on 2, 0. Top function is x take away g of x dx plus top function is root 2 top function is g of x take away x dx. And then what I'll do is it's all of that multiplied by 2 to include the parts for the inverse. All right, so let's get started on that. So it's that. And I've got x take away. Now g of x is when they have the same endpoints. That's g of x with the same endpoints. So I'm going to grab that, or copy it anyway, and just chuck it in there. So that's my bottom function with the same endpoints. Yeah, it's that. We're subtracting. So let's just stick that in some brackets to make sure it executes the brackets okay. dx plus okay, now it's that function with a equals, take away x dx, grab that answer, multiply it by 2, and we've got a quarter. All right, there it is. Took me 20 minutes, probably doing it on the day. That would have taken me easily an hour. Really hard last question, that one.